Another question. An iron rod is 2.58 meter long at 0 degrees Celsius. Calculate the length of a brass rod at 0 degrees Celsius if the difference between the length of the two rods must remain the same at all temperature. So linear expansivity of iron is 1.2 times 10 raised to the power minus 5, and linear expansivity of brass 1.9 times 10 raised to the power minus 5 per Kelvin. Now an iron rod is 2 points, that means the length of iron 2.58 meter long. Calculate the length of, so I'll have it into, calculate the length of a brass rod. At, that means we don't know this one, this length. So now what is linear expansivity? So that means linear expansivity of iron will be equals to change in length of iron divided by original length of iron per degree rise in temperature. And linear expansivity of brass will be change in length of brass divided by original length of brass per degree rise in temperature. So now if you look at the question, which one look alike here? They say if the difference between the length of the two rods must remain the same. The difference between the two rods is your change in length. So if it is to remain the same, so make change in length subject formula here. That means change in length of iron will be equals to, so like over 1 cross multiply. So this will be alpha for iron, length for iron, and change in temperature. Here also cross multiply. Change in length for brass will be equals to alpha for brass, length for brass, times change in temperature. Now if the difference between the two lengths of the two rods must remain the same at all temperature, that means the temperature is also constant. That means this change in length here will be equal to the change in length here. It means change in length for iron is equal to change in length for brass. So our change in length for iron is this. So that will be alpha for iron, length for iron, change in temperature will be equals to alpha for brass, length for brass, times change in temperature. So that is, this will be equal to this, so according to the question. So now we know that theta will go because it's the same. So now if theta is not there, what is alpha for iron? So linear expansivity for iron is given in the question. So linear expansivity of iron is 1.2 times 10 raised to the power minus 5, as in is given. L, length of iron. Do we have length of iron? Yes, that is times 2.58 is also given. Length of iron 2.58, and linear expansivity of brass, so this will be equals to 1.9 times 10 raised to the power minus 5 length of brass. So that's what we are looking for. So now multiply this together. So that is 1.2 times 2.58. So that will give you, I'll just say 1.2 times 2.58. So that is 3.096 times 10 raised to power minus 5 is equals to 1.9 times 10 raised to power minus 5 length of bra. So that means length of brass is equals to, you divide both sides by 1.9. So that means this will be 3.096 times 10 raised to power minus 5 divided by 1.9 times 10 raised to power minus 5. Now 10 raised to power minus 5 will cancel out 10 raised to power minus 5. So linear length of brass now will be equals to, so divide, that will be 3.096 divided by 1.9. So that will give you 1.629 approximately, so in meter. So that is the length of the brass.